Let us go with the definitions of angle of friction, angle of repose, and also we'll prove that angle of friction is equal to angle of repose for a rough inclined plane. Let's begin with the angle of friction. Definition of angle of friction. The angle of friction is defined as the angle made by the resultant of the normal reaction and the limiting friction with the normal reaction. Whereas angle of repose is the angle of inclination of a plane with respect to horizontal for which the body will be in equilibrium on the inclined plane. To prove that the angle of friction is equal to angle of repose on a rough inclined plane, let us consider a body of mass m on a rough inclined plane. The angle of inclination of the rough surface is theta. By increasing the angle of inclination at one end, the body tends to slide on the surface. Then the angle of inclination theta is called angle of repose. The weight of the body mg is resolved into two components. The component mg cos theta acts perpendicular to the inclined plane, and this is equal to the normal reaction n. Thus, we can write n is equal to mg cos theta. Let this be equation 1. The other component mg sin theta acts parallel to the inclined plane and opposite to the frictional force F. Thus, we can write F is equal to mg sin theta. Let this be equation 2. Now, divide equation 2 by 1, we get F by n is equal to mg sin theta by mg cos theta. This mg and mg get cancelled. The remaining is F by n is equal to tan theta, which is equal to the coefficient of friction. Thus, mu is equal to tan theta. When alpha is angle of friction, then for the definition of coefficient of static friction, mu becomes tan alpha. When you compare equation 3 and 4, we can write tan theta is equal to tan alpha. Cancelling tan on either sides of the equation, we get theta is equal to alpha, which proves that angle of friction is equal to angle of repose.